As you may know, there's the freshwater fish here on the left side and the saltwater fish on the right side. Before we plunge us into the theme, we have to talk about the osmosis. The solvent molecules like salt in the cells of the fish and in the water are appearing here in different concentrations. Here we spot that the freshwater fish has a higher concentration of salt in the cells than the external environment. The marine fish face the opposite. Now we take a closer look on a smaller level. The freshwater from the outside wants to pass to the inside. The cells of the fish are hyperosmotic to the surrounding, because they contain more solutes. The sea has more salt than the marine fish. The cells are hypoosmotic. To handle the pour in and pour out, the nature developed the osmoregulation. For better understanding, let's see what is happening when fish have no osmoregulation. Oh, the freshwater fish will grow immensely, while the seawater fish will shrink because of losing water and ions to a minimum. Now we scan for the fish and we try to understand what is going on in relation to the interior design of the animal. So, what is osmoregulation? Here, everything wants to stream in, as freshwater passes through the mouth and skin and diffuses into the blood cells. That leads to an overload for the gills, and they remove a large volume of water by having a high rate of filtration with many large glomeruli. They produce a lot of urine to get rid of the water. This in turn leads to a loss of salt. To solve that, they take up the salt. This is done by special cells in the gills, the chloride secretory cells, by actively transporting the salt into the blood. There is everything streaming out. The water diffuses out and the salt too. That means they do have to drink. They must replace the water they lose because of osmosis. While they are drinking seawater, it entails a large quantity of salt, which leads to an overload for the gills. But how do they remove the salt? This is done by special cells, we heard about them before, the chloride secretory cells. They pump the salt from the blood into the surrounding water. The marine fish urinate a little, by having a low rate of filtration of water into the kidney tubules and a few and small glomeruli. So, now we know that there are osmoregulation systems for hypo or hyperosmotic fish. But there are also osmoconformers like sharks or other jawless agnata. They are able to regulate the water and salt metabolism hormonal by keeping urea in the body and store them in the cells. To do that, they have, I'm sorry I have to say it in German, trimethylaminoxide, in short TMAO. TMAO weakens the harmful effect of urea. In conclusion, some fish have to drink, while others don't. Thanks for watching.